1.6 is classifying polygons. So again, hopefully something that's review. Like I feel like my children are in elementary school and they talk about this stuff, most of it anyways. So it should be review, but it's always good for a refresh. A polygon by definition means many angles. It is defined as a closed plane figure formed by coplanar segments. So it has to be closed. It can't be open. That's one thing. And its sides are segments. So they are straight segments. They can't be curved. Each side must intersect exactly two sides, one at each endpoint. No two sides with a common endpoint can be collinear. And each endpoint of a side is a vertex of the polygon. So just like an angle, the vertex is where the two sides meet. So the first thing you're going to do is just identify if something is a polygon or not. So as you look through these shapes, you want to see, are they closed figures? Are the sides all segments? Does each side only intersect two other ones and all at their endpoints? So if you look at A, would A be a polygon? Yes. So this one is. Is B a polygon? No, why not? Okay, not closed. Is C a polygon? Why not? Good. Sides intersect more than two sides. Is D a polygon? Yes. Is E a polygon? No. Why? So each one had to intersect two other ones, which they are, right? Each one's intersecting two other ones, but where does it have to intersect?
Vertex.
At the vertex or the end points of the segment, okay? So sides do not meet two other sides at the end points. So each side does intersect two other sides, but not at each endpoint. Okay, a convex polygon is one in which no line that contains a side of the polygon contains a point in the interior of the polygon. So basically the test here is if you were to extend the sides of the polygon, would the extended lines cross inside the polygon? If they do, it is not convex. If they don't, it is convex. So if I were to take that first shape and I were to extend these lines out in either direction, any of them, do any of those extensions cross into the center of my circle or into the middle of that shape? No. So this is called a convex polygon. Your book actually just says convex and not convex. Other geometry books call them concave. So sometimes you can just look at it. Like if it's caved in at any point, then it's a no. But if you need to test it out, then that's what you want to do. Just extend your sides. So there's your concave. Oh, I'm sorry, your book does say concave. It's the old book that says convex. Or not convex. Concave means that the lines would extend inside your polygon. So it has a line that contains a side of the polygon that contains a point in the interior of the polygon. God bless you. This time if I were to extend any side, so if I extend this side, God bless you. One does not go through the center of my polygon, but the other one does. So that one would and that one would. As soon as you've got one that does, it is now concave. So think it's like caved in. There's like a little piece of it that's caved in or missing. All right, classifying by the names. So this is straight memorization, right? If it has 3 sides, it's a triangle. 4 sides, it's a quadrilateral. 5 sides, pentagon. 6, hexagon. 7, heptagon. 8, octagon. 9 nonagon, 10 decagon, 12 dodecagon, and anything else, so the n is anything else, is the number of sides slash gon. Like if it was 11, it's 11 gone. Okay? If it's 222, it's 222 gone. Okay? Gon. So I would say the ones that people mix up are the hexagon and the heptagon. Just be really careful. The 6 is hexagon. It has an X, just like the word 6. And 7 is heptagon. The rest of them usually everybody's pretty good at. But this is straight memorization. Equilateral, equiangular, and regular. So equilateral, just like an equilateral triangle. Equilateral means all the sides are congruent. Equiangular means all the angles are congruent. And regular is both equilateral and equiangular. All right, so this one says, tell whether the figure is a polygon and then whether it's convex or concave. I'm going to go a step further and then say, then classify it. So if it is a polygon, I want you to give its name. So if you look at A, is A a polygon? No. Okay, that line in the middle makes it not a polygon. Oops. Because it's not, they're not all connected at one at each endpoint, right? B, is that a polygon? Yes. Is it convex or concave? Convex. If I extend those sides, it's not going to intersect in the center, right? And how many sides? 6, right? Which makes it a? Hexagon. Hexagon. It's okay. It's early to be asking you to count. All right, 3. Is that a polygon? Yes. What's wrong with it? That side is curved. Okay, it's got to be a segment. D, is D a polygon?
Yeah. Yes.
Yes. Good. Concave. Okay, and then it has 12 sides, which makes it a what? Dodecagon. All right, example 2 says classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular, and then explain your reasoning. So what makes it equilateral? All the sides are congruent to each other. What makes it equiangular? All the angles are congruent to each other. What makes it regular? Both. So if you look at A, first of all, let's classify it. 1, 2, 3, 4, 5, 6 makes this a hexagon. Is it equiangular? Yep, all the little arcs have one single arc. They're all marked as congruent. Is it equilateral? Yep, which means it's also regular. So it's all 3. Equilateral. You're going to put all 3. How about B? How many sides?
4.
Which makes it quadrilateral. Is it equilateral? No. So this pair have a 2 tick mark. This pair have a 1 tick mark, right? Is it equiangular? No, which means it's also not regular, right? And it says explain, right? All 4 sides, not all 4 angles. Then we look at C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. Makes this a dodecagon. Is it equilateral? Yes, all the sides are marked as congruent. Is it equiangular? So be careful, right? Because look, this angle matches this angle, but this angle it's on the wrong side, right? Which means they are not all congruent. So, I mean, that's the entire purpose of this question, so be really careful. Every interior made like that would have to be congruent.
Wait, what?
The angle formed by these two sides right here is this obtuse angle. That doesn't match these right angles. This angle formed by those two sides, every angle, so that's a vertex, right? Every vertex angle has to be the same. The exterior angles on those are the same, but not the interior angles. Questions on any of those? Okay. Oh. Now we get the algebra brought back in, right? So it says the table is shaped like a regular hexagon. The expressions shown represent the side lengths of the hexagonal table. Find the length of a side. So what do I know about a regular hexagon? 6 sides. What's true about the regular part of it? All the sides would be equal. Same with the angles, right? So if they give me 2 side lengths, what do I do with those? Set them equal to each other. So 3x plus 6 equals 4x minus 2. Subtract the 3x. Add the 2. X equals 8. Okay, but again, it's not asking just for x. It's asking for the side length. So I got to plug it in. Does it matter which one I plug it into? No. Nope, they should be the same. So 3 times 8 plus 6. 24 plus 6 is 30. I'd actually say if you had an extra minute on your test, check by plugging them both in. 32 minus 2, and that's 30. It confirms your answer. So the length of a side would be 30, and this time I gave you a measurement, inches. It would be the same if they gave you angles, right? Doesn't matter if they're sides or if they're angles. If they're regular, then you can set them equal to each other. Questions?